On 113, you guys, it says, we know that this function that's shown as a piecewise function, so from the left and from the right, there just is potentially going to be a break, but they said it is continuous, so there's not going to be a break. If it's continuous, from the left of 4 and from the right of 4, they have to equal each other. So what would k have to be at that break? AP is 100% going to ask you one of these in a multiple choice form question, 100%. We know if something's continuous, from the left and the right of where the break is, they have to equal. So what do you think I could do here with these two equations? We did one of these on Monday. Set them equal, you guys, so we can say, all right, from the left and from the right, they have to be equal. Where is the only place for a potential break? At 4. So what am I going to go plug in for x? You know it, Mar. So I'm going to go take when x is 4, plug it in right there. So I'm going to get 4 squared, or 16 minus k, equals negative 12 plus 18. 16 minus k is 6. What's my k going to be? Did I mess up?
No. I think.
Yeah. Okay. Who'd you guys get? 10. So now let's feel comfortable doing that same thing with our calculator. They said, hey, here's another piecewise function. K is a constant. What value of k makes this function continuous? So for something to be continuous, where's this potential break? At 5. We just need to set the top and the bottom equal at 5. So I'm going to say, all right, 12 over k cubed plus 5 has got to equal k squared minus 5. Maybe you write it yourself a little note. I'm going to type this in as y1. I'm going to type this in as y2. I'm going to find their intersection. y1 and y2, what are we going to use for k? Yeah, just use an x, you guys. 12 over x cubed plus 5. K is just a variable, you guys. Then I'm going to have my y2 as x squared minus 5, and I'm going to graph them. So I'm going to do second trace. What am I doing? Thanks. Second trace. Option 5 is intersect. And then what does your calculator say as the options? First curve. So you want to just move your little cursor close and hit enter to where they intersect. Move your cursor again and close to that intersection and hit enter. Then hit enter one more time because they want you to quote unquote guess. I'm not here for a guess. What did you guys get for your intersection? 2.377 agreed, and then 0.651. Yeah. And they just said for what value of x. So we just care about this 2.377. So now this one says, hey, the function defined above, for what value of a makes that function continuous when x is 3? What are we going to do? Plug in 3 and? This one I don't think we're allowed a calculator. It'll say calculator active, yeah. Meanies. We got a squared plus 3 squared equals a times 3 plus 3. And maybe you didn't write it out that way. Maybe you just jumped to a plus 9 equals 6a?
Yep.
I squared right here. Boop. There we go. That's a game changer. What are we going to do if it's squared?
Square root.
What do we have to do? It's a quadratic, though. We have another a.
Subtract 6a and
We got a toot, y'all. Right? Because it's 1a squared. We got an a squared minus 6a plus 9. Woof. We got to go factor that. What multiplies to be 9 and adds to be negative 6?
negative 3 and negative 3.
Oh, nice. Okay, he said a minus 3 times a minus 3. Negative 3 times negative 3 is positive 9, and they add up to be negative 6. Well done, Ritz. So what's my a value going to be?
3.
That's going to make my function continuous. Boom. Guys, this one's good practice for unit circle stuff. Again, it will have to say calculator active for us to be able to use a calculator. This one, it doesn't. So they're curious, when is the function continuous at 0? What are we putting where? When x is 0, where are we putting that? For every x. But wouldn't that get me 0 over 0?
Yep.
Do we know a fancy little, again, we're looking at 0.
The sine of 3x over 3x would be, is that what you're getting at?
Yes, exactly. Let's take a reminder. The sine of 3x And he's saying over 3x. As we look at x is 0, what's that going to be, that limit, as x is 0? It's going to be 1.
So take out 2 and 1.
Yeah, so let's go write ourselves a little reminder. So we're saying the sine of 3x over 6x has to equal c. That's just me setting this top one equal to the bottom one. But if I plugged in that 0, we're going to get 0 over 0. And that's not the case. But again, we're looking as x approaches 0. So and this is again, I'm doing this because we haven't talked about this all week this week. As x approaches 0, we know the sine of 3x over 3x is 1. What do I need to multiply this by to not change my problem?
1/2.
Right? Sine of 3x times 1 would get me sine of 3x. 3x times 2 would get me a 6x on the bottom. And then that has to equal c. Again, that's just me saying top function equals bottom function. What do we know this limit is because we're geniuses? This limit is 1 because of that graph over there, and we have to have that one memorized. 1 times a half. Final answer.
0.5.
You got it. So this one says, hey, here's this function again. Where is my function continuous? And again, to your point, Biscuit, for what value of c is it continuous for all x's? Okay, so they want us to go find c. What are we going to plug in where? And I'm going to write this out personally. 4 minus cosine of -1 equals c plus 5 ln of -1 plus c. Again, I'm just plugging in negative ones in for my x's.
Is there any reason for that?
Ooh,
Because of the negative 1.
exactly, yep. y1, y2, make sure we're in radians, and here we got it. Check this out. In this graph of 114, this is saying, hey, C is this vertical asymptote. So if you want to even make this a little bit more known, that's where C is right here. Because they said, hey, as x approaches C from the left side, what would you say that is on this picture? As I approach C from the left side, what's this graph doing? It's going to infinity, or we could say, does not exist. Very good. What about from the other side? Does not exist or infinity. Agreed. Therefore, the limit as x approaches C does not exist. Right? Whenever we're going to infinity, doesn't exist. How about this one over here? Again, C is just this line here. As we approach C from the left side, negative infinity or does not exist, either one. C from the right side, infinity or
Does not exist.
therefore C from both sides.
Does not exist.
Yeah, what are we noticing with vertical asymptotes? Those limits don't exist. Agreed. A little redundant, you guys, as we're approaching from the negative side, if this is C still, those limits all do not exist. How about that? Save yourself some pen. This one's a little funky. Your picture probably doesn't show up very well. Let me show you. Okay. The limit as I approach C from the left side. Does anyone see what that is actually? It's an L, yeah. So that's the point in case you're curious. Doesn't really matter, but that's going to be L. So I approach C from the left. What about C from the right? Doesn't exist or infinity, whichever one. How about C from both sides? Doesn't exist. They're not coming together. So now this says, evaluate the limits if it doesn't exist, provide a justification as to why. Oh my gosh, do I really care about that? Oh yeah, they're asking for, is there a vertical asymptote? Okay, you guys, is this graph going to have a vertical asymptote?
Yes.
Yeah.
When is this denominator equal to 0? X is 4, right? So write yourself a little reminder, oh, that's going to be a vertical asymptote at x is 4. And maybe you write yourself a little reminder, that's when the denominator is 0. So this question says, hey, what's the limit as x approaches 4? Well, at 4, we've got a vertical asymptote. We've got a vertical asymptote at 4. So we're either doing this, or we're doing this, or we're doing this. Regardless, what's my limit? Does not exist. Anytime I go to infinity, negative infinity, or my fingers don't come together, does not exist. So that's my answer. And my rationale is because there's a vertical asymptote there. Oh, this one. Where's it gonna be a vertical asymptote on that guy?
2.
2. So we know we've got a vertical asymptote at x is 2. And Biscuit on this one, they said, well, I don't care about 2 totally. I only care about 2 from the positive side. But regardless, you guys, if I got a vertical asymptote, what am I doing? So what's that limit going to be? Ooh, does not exist.
It's never going to be a one-sided vertical.
I know, yeah, that's a good point, considering we did just look at this one. No, I've never seen AP actually give that to you. Yeah, in a form of an equation. Yeah, good call, Ritzy. Again, I was a little redundant. This is really just like, can we remember what the graph of 1 over x looks like? 1 over x. 1 over x goes like this, boop, and like this, boop. Yeah. So at 0, what do we have going on at 0? We got a vertical asymptote. Does that make sense? Because would my denominator equal 0? When x is 0, right? Because it's just an x. So we got a vertical asymptote there. So let's just go ahead and, okay, let's do it from the right side. What would you say the right side is? That limit. The right side is 0. Positive infinity, I love it. Or you could say does not exist. What about from the left side? Negative infinity, or does not exist. Therefore, from both sides, it don't exist. And if this is the graph of 1 over x, what happens when you square anything? They all become positive. So if this was the graph of 1 over x, oh gosh. Okay. These negative ones have to become positive. Boop. This is the graph of 1 over x. It just goes like this. Boop. And 1 over x squared, my bad. They just all become positive. So as I approach 0 from the left and the right, what do y'all think? Yeah, it's just all going to be positive infinity, positive infinity, positive infinity, or does not exist. Huh. Does the first one, vertical asymptote at -2. There is a hole. Do you guys agree this one has an x plus 2 and this one has an x plus 2? So I could get rid of one of those. But then do I have a vertical asymptote? I still have one left down there, right? So wouldn't I still have an x plus 2 down there? So I'd have a vertical asymptote at -2 on that one?
Yeah.
Because I'd still have one. I dig it. What about the next one?
Wouldn't it still be squared though?
Oh, Lob, did I have 3 down there? Sure would. Appreciate you. So you're saying it'd be squared and that one would be gone. Thanks, Lob. Still gives me a vertical asymptote there, right? I dig it. How about this one? Vertical asymptote?
Yep.
Denominator 0. I agreed. How about this one?
Nope.
No, this one, these would cancel out. I would have a hole at -2. Where would my vertical asymptote be? 3, very good. How about this one?
Between
This one has no vertical asymptote. Does this have
it does have a hole.
a hole? Yeah. Good, good, good. Okay, let's take a peek at this table. It is known that this limit as x approaches -6 is negative infinity. I'm going to give you guys a second. As x approaches negative infinity, this limit is, as x approaches -6, the limit is negative infinity. Give it a shot. As we're approaching -6, from the left and the right, which y values are going down to negative infinity? A. Agreed. They're going down real quick and real quick there. B is not in the runnings because they specified that it has to be going to negative infinity. And I agree from the left side, it's approaching negative infinity, but from the right side, it's approaching positive infinity.
It's the same problem as C.
And they wanted, as we approach -6, from both sides.
Oh.
Right? Because it didn't have the little exponent there. Does that make sense, Ritzy? Yeah. Great
It
question.
didn't have the superscript.
Right. Okay, if M is continuous, which of the following must be true? I think these are hard. To me, this is like 4 questions in one. Which one must be true? I'm a visual person, you guys. If as x approaches 9, my limit goes to negative infinity. As x approaches 9, my limit goes to negative infinity. What do I have at 9? A vertical asymptote. Because if I'm going to negative infinity, I've got to have a vertical asymptote. So I'm a visual person. As x approaches 9, 1, 2, 3, 4, 5, 6, 7, 8, 9, great, boop. As x approaches 9, we've got negative infinity from both sides, because that's what this is saying. Which one must be true? Do we have a horizontal asymptote going on? We don't know. We have no idea. We don't know anything about horizontal asymptotes. Vertical asymptote. Would that be at y equals 9 or x equals 9?
X.
Vux, a vertical line is vux, right? They're just trying to confuse us. They'll do that. They do something like that, and you're like, I use this silly thing called Hoy and Vux, and I know better. Okay. Okie dokie.
I know there's
Here we go. Again, let's try to visualize this. The values of a function can be made arbitrarily large. What's that a fancy way of saying? Infinity. By taking x sufficiently close to 2. How do I show that in calculus terms? Yeah, as x approaches 2. So this is just fancy for saying as x approaches 2. This is saying that limit is going to be infinity, but not equal to 2. Right. As x gets sufficiently close to 2, but not equal to 2, that's why we use an arrow here and not an equal sign, which the following must be true. Which one do you think is this new notation? As x approaches 2, my limit is infinity. So this is 115. This should be g of x equals 3x to the 4th. And anyone have any ideas what that shape is going to look like? 3x to the 4th plus who cares? What's the shape of that graph going to be? Down, up, what do we think? Straight? Since it's x to the 4th.
It's gonna be like
X to the 2nd, x to the 4th, x to the 6th, x to the 8th. It's all got this same end behavior. If it was negative x squared, negative x to the 4th, negative x to the 6th, it's just doing stuff like this. But anything with an even exponent is going to look like a parabola. This doesn't affect it. Check this out. Look at these graphs. So let's go, boop, looks like that, and that one looks like that. Again, it doesn't matter where they are, but it says for small values of x. So we could say the limit as x approaches negative infinity of my function. What are they going to?
-4 positive.
Well, on this one,
Is that what it says for x approaches plus or minus?
oh, yeah. You're right for the next one. Okay, so I could say either way, boop, boop, plus or minus infinity. So if I'm going left or right, what are these values going to?
Positive.
Infinity, agreed. So of my function, that's just going to be infinity or does not exist. I'm going to even write that, or does not exist. Either one works. So you guys, the biggest exponent on the top, shape, and the biggest exponent on the bottom is going to dictate what this horizontal asymptote is. So if I were you, I would write yourself a little note. This right here is asking for a horizontal asymptote. As x goes to infinity and negative infinity, that's asking where that horizontal asymptote is. So let's do an example of that on problem 1. What's my biggest exponent on top? Yeah, what's about the bottom? When they match, that's all that matters. So that's the only thing that's going to dictate it. What's 10x to the 3rd over 5x to the 3rd? What's going to cancel out?
It'd be
X to the 3rds cancel out. I'm left with 10 over 5, which is just
2.
2. Those are my favorite. Will AP give you a multiple choice like that? Yes. Those are my faves. If those exponents cancel out, we're good. But are they always going to cancel out? Of course not, right? Sorry. Biggest exponent on the bottom, I agree, was 5x squared. So I'm going to write a 5x squared on the bottom. What about on the top? Yeah. And we're looking as x approaches infinity. Huh. Here's why. Yes. What cancels out here, you guys? Well,
2x.
when 2 of my x's cancel out, so I'm left with, as x goes to infinity, I'd be left with 2x to the 3rd, because 5 over 2, 5 minus 2 is going to get me 3. My 10 divided by 5. Does this, as x goes to infinity, you guys remember what an x cubed graph looks like? As x goes to infinity, what's this doing? It's going to infinity.
It's odd.
So we would say this either does not exist or goes to infinity. There is no horizontal asymptote because the exponent on the top was bigger, guys. Whenever that exponent on the top is bigger, there's never going to be a horizontal asymptote ever. When those exponents match, it's going to be where their coefficients are. What do we think is going to happen if the exponent on the bottom is bigger? Let's take a peek. What's this graph looking like? As x goes to infinity. As x goes to infinity, what's this limit going to be? 0. How about as x goes to negative infinity? 0. What's with my exponents? Where is it bigger? On the bottom. Interesting. So we know this answer is going to be 0. to the 5th over negative 5x to the 7th. What cancels out? Yeah, how many x's? 5. And then do you agree I'd have a negative 2 on top because of 10 over negative 5? And then I'd have 2 x's on the bottom. What happens when I take negative 2 and I divide it infinitely many times?
You get 0.
Yeah, if I'm taking any number and I'm dividing it by infinity squared, it's going to be so little. Any number divided infinitely many times is going to be 0. Me as a student, I would have memorized these rules. Me as a teacher, I'm trying to teach you the why. If I was a student, here's what I would have memorized. If those exponents match, it's just those coefficients divided. 10 over 5, boom, is 2. If the exponent on the top is bigger, I'm never going to have a horizontal asymptote. If the exponent on the bottom is bigger, it's always going to be 0.
No.
You as a student, for the y, it's when these cancel out, what are we left with? When these cancel out, when I'm left with 2x cubed and I plug in an infinity right there, 2 times infinity cubed is going to infinity. That doesn't exist. And then here, when I plug in, again, when I cancel out what's left, I'm left with an x squared on the bottom. When I plug in that infinity, I'm dividing negative 2 infinitely many times. Okay, as x goes to infinity, you guys, maybe you just write yourself a little reminder. Whenever they're asking that, they want to know what your horizontal asymptotes are. That's what they want. With just using symbols, that's what they're asking. What about the first one? What happens with my exponents? Hey, I'm left with 1x squared over 2x squared. My x squareds are going to cancel. What's my horizontal asymptote here? You got it. Whenever those... No, please. Love it. How about this one? Ooh, be careful. Where's my biggest exponent? Ooh, it's actually 3x cubed. Did I move it? I moved it. This biggest exponent is 3x cubed. What about on the bottom? 2x to the 5th. Be careful. AP will do that. AP will do that. Does anything cancel?
Yes.
What would that be?
0.
3 over 2x squared? Is that right?
Which would be...
And if you put in infinity on the denominator ever, if I take any number and I divide it infinitely many times, what are we getting? 0. But if Biscuit's like, dude, I'm a memorizer. I know the exponent on the bottom is bigger. 0. Done.
Yeah.
How about over here? Biggest. Yeah. Biggest on the bottom. What cancels out? An x. What happens when you plug in infinity to this now, Marmar?
You get 3 infinities.
3 infinities is going to be
Infinity.
infinity or does not exist. Either one of those is great. This one's saying, hey, which of the functions will have a horizontal asymptote? Biggest exponent here. 3x, negative 3x cubed. What about on the bottom? 2x squared. Bigger on the top. That means I'll always have a variable on top. And when I plug in infinity, it's going to be infinity. So this is going to be does not exist. How about number 2? Which ones do we care about? X squared on the top and what on the bottom? X cubed. Wouldn't I be left with 1 over x there? And what happens as I plug in infinity down there? 0. You got it, bud. So that one has a horizontal asymptote of 0. Option 3. Say it again. This, yes, to the 4th on the top is to the 2nd on the bottom. So when things cancel out, wouldn't I be left with 3x squared on top? Yeah, as x approaches infinity, that would go to infinity. So it doesn't exist. Final answer? Yeah, a horizontal asymptote of 0 works. It can be 0. Okay. Ooh, they're trying to trick you on this one. What happens here? What can we do to that top?
Square root it.
Yeah, exactly. You guys, if we're really just comparing the biggest exponent, it's here. We only have to worry about that 9x to the 6th. What happens when I square root that? I'd get 3x to the 3rd, right? And what do I have on the bottom? Right, final answer. 3/4 would be your horizontal asymptote. Very good, Hen.
Do you even have to worry about that -3x?
You do not, because the biggest exponents are what dictate that shape. This is like your little brothers and sisters annoying you. This is what dictates the shape. Great question. Cool? Okay. Ooh, this one. What do we have to worry about on top? The square root of 4x to the 4th is going to get me 2x squared. What about over 7x squared? It's just going to be 2/7. It's just going to be 2/7. Okay, then this is the last thing I want to end on. This is great. Okay. Well, let's just do this. This is a lot of words. This is a lot of type. What's the only thing we care about in the numerator? What's the only thing we care about in the denominator? Final answer for that horizontal asymptote? Done. Boom. Find this guy. If I plug in infinity here, correct me if I'm wrong, wouldn't this be infinity over infinity? Whew, that's insane. Could we break this down? We got this.
5x over x plus sine of x over x.
You got it.
And then that'd be 1.
Close, be careful, because this limit is different this time. As x approaches infinity as 0. Very good, Ritz. Very good. There is a trick on that. So you're right. I just broke it apart. And let me just remind you what that sine of x over x graph looks like. And then you're right. We're used to looking at it as x approaches 0. But this one's saying as x goes to infinity. Yes. So you guys, as x approaches infinity, when you say these y values are going to 0, so this limit, this is going to just get me a 5, plus this is going to get me a 0. Final answer? 5. Okay, we've got to sketch a graph that satisfies all 1, 2, 3, 4, 5, 9 of these things. Whew! Is there a point? Do we know that there's a point that I could just go to? F of -3 is 1. So you guys, this point, -3 is 1. Boom. I'm just going to draw myself a point, and I'm going to say I took care of that. Then I want to know, is there a vertical asymptote? What would make something need to have a vertical asymptote? Where would my limit need to go to? Infinities. Do any of these limits have infinities?
Yes. X approaches 4 from the bottom.
Hey, he's looking at this one and this one. As I approach 4 from he started with the positive side, I'm good with that. As I approach 4 from the positive side, I need to go to negative infinity. So I'm going to go to 4, and I'm going to go put a vertical asymptote in there. And this says, as I approach 4 from the positive side, I've got to go to negative infinity, bless you. 4 from the positive side, I got to go to negative infinity. I'm going to just go like this. I don't know quite where I might pick up over here, but I know that as I approach 4 from the positive side, I got to go to negative infinity. What about this one? 4 from the negative side. Where does that need to go? I got to go to positive infinity. So 4 from the negative side, wouldn't I have to go up there somehow? Again, I'm not going to connect it over here yet because I don't know what else has to go on, but I know I've got that little part. And then I've taken care of these 2 items. Psh, psh. Would I have any horizontal asymptotes? Horizontal asymptotes are when I go x goes to infinity or negative infinity.
As x goes to infinity.
Yeah.
Asymptote's 5.
Yeah, he's saying, okay, as x goes to infinity, I was supposed to highlight that. As x goes to infinity, my y's have to go to 5. So as my x's go to infinity, my y's have to approach a 5. So he's saying that means that I've got a horizontal asymptote at 5. And as x goes to infinity, my y's have to go to 5. So what that means for me on my graph is this guy needs to connect and then start leveling off at 5. So I'm going to go ahead and connect this. And I'm going to say, all right, this needs to go connect off to the right. Riley's might be like more, Riley's might be more like this. It doesn't matter. They have the same general shape. They follow the same trend. And I've taken care of that one. Whew. Those to me are all the vertical and horizontal asymptotes. Now we got to go build in some other stuff. As x approaches -3 from both sides, my limit has to go to -2. As x approaches -3, my limit has to go to -2. So I'm going to go this. I'm going to be like, woo, woo. I'm going to say, all right, as I approach -3, I need to stop at, my fingers need to come together at -2. I'm going to put a hole there because I already have a point when x is -3. They both could not be filled in there because then it wouldn't be a function. But this part right here is me satisfying this. How about -1 from the positive side? -1 from the positive side. I got to get 4. -1 from the positive side. I got to go to 4. This is funky. -1 from the positive side. I got to come in at 4. So I'm just going to do this. And if you can see what I just did, I just came in there. Cooper might come in from the bottom. It doesn't matter. But as I approach -1 from the positive side, I got to stop at 4. I'm not going to put a point there or a hole yet because I'm just kind of curious. But that satisfies that. There's a lot going on here. Oh, does this one still work with what you said, Ritzy? As x approaches -infinity, we got to be going to 5?
Yeah.
Yeah, so we still have, as we go to -infinity, but I'm not ready to connect that quite yet because something else might go on. Who knows? As x approaches 1, we got to end at 3. As x approaches 1, we've got to end at 3. Wow, this is in all sorts of weird orders. As x approaches 1, so you might erase something. As x approaches 1, we got to end at 3. So you might have to erase. This is like a little work in progress. I'm going to say, all right, as I approach 1 from both sides, I'm going to end at 3. Since it's a limit, you can always have a hole or you could fill it in. Okay, I did this one. And the last thing, as x approaches -1 from the left side, we've got to be at -4. Holy moly. As I approach -1 from the left side, so I had drawn this. I'm going to have to erase it because I'm going to have to go down to -4. As I approach, oh no, that's not -1. No. What did I do wrong? Oh gosh, that's not true. As x approaches -1 from the negative side. My thing is glitching. Okay. As I approach -1 from the negative side, oh, I got to go to -4. Yeah. So that's going to have to be down here. 1, 2, 3, 4. Psh. So I'm going to erase this little guy, and I'm going to connect these here. Wow, this one was madness, you guys.
Yes.
That was too much. I put one on your formative, and it is way less than that. That was insane. Jeez. So what would I personally do now is I'm going to connect some things. I'm going to say, all right, this needs to, I can now connect this stuff. Boom, I'm going to connect that guy. As I approach -infinity, my y had to go to 5, so I'm going to go connect that, and I'm going to say level off there. That was a lot.